Alright, so the first thing they want us to do is move all the terms to one side to get 0 on the other side. Alright, so we have 4x squared plus x is less than 14x minus 12. So I'm going to subtract 14x from both sides. That'll give me 4x squared minus 13x. And I'm going to go ahead and move the negative 12 to the left side, making it positive 12. And that concludes the first task. So we have moved all the terms to one side, giving me 0 on the other. Now, the next thing they asked me to do is completely factor the non-zero side. So first I would check for a GCF. There's nothing in common between these three terms. In order to, so there's no GCF. I can't factor anything out there. It's a trinomial, and when a trinomial factors, it'll factor into two binomials. But it turns out that this trinomial actually doesn't factor. One way to check to see if a trinomial will actually factor or not before spending, like 30 minutes trying to find the right combinations is we can calculate the discriminant, the b squared minus 4ac. In order for a trinomial to be factorable, the discriminant has to be a perfect square. So b is negative 13, so we have negative 13 squared minus 4 times a, which is 4, times c, which is 12. And so we have 169 minus 4 times 12 is 48, and 48 times 4, I believe, is 192. But I'm going to check that on my calculator just to make sure. 60 times 12, yep, 192. And 169 minus 192 is a negative number, and so I can tell that this isn't factorable, but just with my calculator, 169 minus 192 is negative 23. So the discriminant turned out to be negative 23. Alright, so this trinomial, normally a trinomial would factor into two binomials, but it turns out this one doesn't factor. In order for a trinomial to be factorable, the discriminant, b squared minus 4ac, has to be a positive perfect square, like 9 or 16 or 36. So the discriminant turned out to be negative 23. Not only is it not a perfect square, which means it doesn't factor, but it's a negative number. That means, that this doesn't even have any real solutions. So the goal was to completely factor the non-zero side. But since it doesn't factor, it's prime. And so there are no boundary points. Since the discriminant is negative, the equation 4x squared minus 13x plus 12 equals 0 has no real solutions. So there's no boundary points, and the solution set is the empty set, that there's no solution. And so we see that they've selected no solution. The solution set is the empty set and no boundary points. So this is sort of an unusual one. Normally at this step right here, what would happen is we would factor it. Let's say for a moment that it factored to 2x plus 1 and x minus 3. Let's just say that it factored to that. Then what we would do is we would proceed to set each factor equal to 0, and the solutions that we got right here, those would be the boundary numbers. Those would be the boundary points. So if the trinomial was factorable, then we would set each factor equal to 0, giving us the boundary points. But again, it turns out this one doesn't factor. And we can verify that by calculating the discriminant to see if it's a perfect square.